Okay, in this video, I'm going to show you how to make another prediction. In this case, we're going to be making a prediction for world population. And so here we have years since 1950 in world population. So in the year 1950, so that would be 0 years since 1950, population was about 2.5 billion. 40 years later, so that would be 1990, it's about 5.3 billion. 60 years later, 2010, that was 6.96 billion. And 70 years later, according to the best estimates from the United Nations, we're at about 7.79 billion. Okay. So what I'm going to do with this is I'm going to try to make a prediction with this data. And so here, I'm going to copy this data once more. I'm going to go to Desmos. Just going to paste it in here. The nice thing is if you paste it in, it's going to scale the graph for you. Okay. So if you have trouble with this, I recommend you just refresh the graph, start from scratch, and paste it in right away. Otherwise, you'll have to manually set the scale. But the nice thing is if you paste this data in right away, it's going to show you the scale over here. Okay, so what I'm going to try first is I'm going to try an exponential function here, because it looks like it might be curving slightly as we go. So y1 is approximately a times b to the power of x1 plus c. Okay, and that gives me my exponential curve. And that tells me if I want to make a prediction and I want to see in 100 years, what do I think the population might be? As I go along this predictive curve, I'd say that in 100 years, so in the year 2050, it'd be about 11 billion. Okay. Now, as you can see from this exponential curve, sometimes we see something that might be might seem a little bit odd, but it's going to keep growing without any boundaries. And so that's why I want to introduce you to another type of function. This is a very complex type of function, but it is extremely useful. And it's probably one that you've seen in the news quite a bit recently. So what I'm going to show you is I'm going to show you another function. This function is what's called a sigmoidal function. Okay, so I'm just typing that on the side there so you can see it. So a sigmoidal function, I'm going to use that to make my prediction. And so here, I've got y1 is approximately. Now here's where it gets a little bit funky. So what I'm going to look at is I've got a over 1 plus e times 2.718. Now, if you're taking calculus, you might recognize that 2.718 is what's called the base of the natural logarithm. So it's a very important natural number, and it occurs when we're looking at natural growth to the power of cx1. Okay, so a, b, and c are our parameters. All of these values for a, b, and c give us a certain parameter for this. So a happens to be 12, c is negative 0.02, all of these values. So it's making us a prediction for what these values might be. Now let's notice what happens with our curve. So over here, in the short term, we only look at the last 50 years or 70 years here. This model seems pretty much like a straight line. But as we zoom out, this is what many people think is actually going to happen, is we're going to follow this sigmoidal curve. And as we follow this sigmoidal curve, what's going to happen is eventually we're going to level off. And this is what's known, and we are actually seeing this right now. When people talk about flattening the curve, this is exactly what they're saying. We don't want an exponential curve, we want to have a flattened curve. And so according to this, after 80 years, population would be about 8.5 billion, so that's the year 2030. After 100 years, so that's the year 2050, we're going to be at 9.8 billion. But here's the interesting thing. So with the exponential model, it seemed to go on forever. With this, we hit a holding point of around 12 billion. And so the world population seems to hold steady around 12 billion if we use this model. And this is a model that we've noticed seems to work with a lot of population growth. So this is something that you might want to think about. Although it's a complex looking formula, this is something that you might want to think about for your project, or your upcoming project, as you're starting to collect some data and trying to see how is this changing over time. All right, so we've got our exponential curves, we've got our sigmoidal curves, and we also have our linear functions that we can use to make our models. All right.